Okay, hi there. Today I'm going to be covering chapter 9-7, which is linear, quadratic, and exponential models. So first I want to quick touch on what each one of those types of equations look like. Linear is something you should be very familiar with. You know, that's y equals mx plus b. Maybe it would be y equals 3x plus 2, or y equals negative 2x minus 1, something like that. The exponent on the x is a 1, which is implied, and the exponent on the y is a 1, which is implied, because they're regular x's, regular y's. Then there's quadratic. Quadratic is where I've got an x squared in there. And it usually falls under the type of equation like y equals ax squared plus bx plus c. You know, y equals 3x squared minus 4x plus 5 or something like that. All right, so that's what quadratic equation looks like. The last one is an exponential one, which means the variable's in the exponent. You know, and we covered some of this where like y equals a times b to the x. All right, y equals 3 times 2 to the x power or something like that. Now, what each one of these looks like on a graph is going to be important in this section. You know, if I draw a quick graph of each one of them, linear has the word line in it, and that's what it should look like. It should look like a line, you know. And quadratic we just covered, that's going to have a parabola. Now, whether it opens up or down depends on a, whether a is positive. If it's positive, it opens up. If it's negative, it opens down. I'm going to draw one that opens up. So, you know, look something like that. And exponential model is a little different. That one's a curve. Draw one of these. You know, and with most of them, if it's exponential growth, it's gonna go up and start get real big real quick. Okay, so that's what the exponential graph will look like. Okay, all right. So those are your three different graphs, and we're going to talk about how to differentiate those three things. So the first problem I'd like to do with you guys is this one where it says graph the points and choose which model is most appropriate for the set. For the set. Okay. And they give me a bunch of points here. They give me 1, 3, 0, 0, negative 3, 3, negative 1, negative 1, and negative 2, 0. All right, so I'm going to go graph these points. Let me make a quick graph here. All right. Okay, so let me plot the points. I got 1, 3, that's here, about there. 0, 0 is right at the origin in the middle. Negative 3, 3 is negative 3 left and up 3. Remember, this is the y-axis, this is the x-axis. Negative 1 is here, and negative 2, 0 is here. So if I connect these points, what does the shape look like? Kind of missed that one. So this looks like, you know, and you can always scroll back, look up there, that looks like a parabola, which looks like quadratic, okay? So that would be your answer is quadratic, okay? Which would also look like a parabola. Quadratic is the answer you're looking for, okay? So that was the first one I wanted to cover with you guys. Second problem, the next couple problems are actually all going to be looking at a table and determining which kind of graph it's going to be. determine what kind of function it is. All right, so I got a x and y. -2, -1, 2, 0, 5, and 1, 8. Okay, so the x part of the table, the x values, those goes up by 1, so it's consistent. There's not much to analyze there. However, if I take these and I figure out what's the spacing between these, well, 8 minus 5, that's 3. 5 minus 2, that's 3. 2 minus -1, that's 3. These are all the same, which means if that's the rate of change between the y values, which means this is going to be a linear model, okay? Because, yeah, that's the slope. Rate of change is all the same. Slope would be 3 in that case, all right? Going up 3. Okay, number 2. It's the same thing. I'm just going to put a new, it's number 3. Same directions. New table. So this one goes -2, -1, 0, 1. This one goes 0.25. This one goes 0.5. This one goes 1 and 2. All right, so quickly if I start looking at this, 2 minus 1 is 1. 1 minus a half is 1/2. 0.5 minus 0.25 is a quarter. They're not all the same, which means this is definitely not a linear kind of equation. I usually try to knock out a linear right away if I can, or if it is linear, then I got the answer. And then I start looking at the table, look at the y values. What's going on with that? How do you go from 0.25 to 0.5? How do I go from 1/2 to 1? How do I go from 1 to 2? Remember, 0.5 is 1/2. And what you find is that, to go from here to here, you're doubling it. You're multiplying by 2. So if you're multiplying over and over again to get the next value in the y column, that's exponential growth. And that's the answer I'm looking for in this case. All right. Number 4. Same thing. This one goes -1, 0, 1, 2, 3. All right, and I got 1, -1, 1, 7, 17. Okay, so, I look at this quickly and I subtract the numbers. If I subtract 17 minus 7, that's 10. 7 minus 1 is 6. That one's 2. Okay, this is not linear, clearly. What about if I multiply? If I go multiply to get from -1 to 1, that's times -1, 1 to 7, that's times 7, 17 to 717, that's a decimal. It's not constant that way either, which means, I got to start taking another crack at this. Maybe I'll start subtracting the numbers, and we'll see what we get. 17 minus 7 is 10. 7 minus 1 is 6. 1 minus -1 is 2. And -1 minus 1 is -2. So that didn't work. So linear is out. There's a way to check to see if something's quadratic, and that's to go out another level. In fact, if you keep going, eventually you'll find out what the exponent on the x is. I'll get to that in a minute. So if I subtract again, 10 minus 6, that's 4. 6 minus 2 is 4. 2 minus -2, that's 4. So these are all the same, which means this is actually, means I got an x squared in that equation, is what that means. So the answer is quadratic. You don't have to know this, but I'll show you anyway. Suppose I went out one more level. You'll learn this in Algebra 2. If I went one more level out, and finally I got all of these to be the same, and it took me like 1, 2, 3 levels out, that means I would have x to the third power. So that would be the exponent on the x then. This is actually the exponent would be 1 here, which would make it a linear because it's the first one, which is what we covered in the first example. If the second one has, all the same numbers here, then that's x squared. So I'll erase this because you don't have to know that, but you need to know the quadratic, linear and quadratic, okay? So that was that problem. And believe it or not, I think that's all I got for right now for today. Have a great night, and I'm going to close it out with a little bit of music.